Let's find out how do we solve these type of quadratic equation questions. A train travels a distance of 360 kilometers at a uniform speed. If the train had gone 5 kilometers per hour faster, it would have completed the journey 48 minutes sooner. What was the original speed of the train? So let's try and visualize this a little bit. So what is going on here is that a train covers a certain distance, right? So we actually need to find out the speed. So we know the relationship speed is equal to distance divided by time, right? So initially, let's say the train was going at a certain speed of x. So it went from here, our starting point, to let's say the end point here. And it was traveling at a speed of x kilometer per hour. Now, what we have been told is that if the speed were x plus 5, if the speed were x plus 5, it would have reached the destination sooner. So in other words, if you find out, so from here, let's find out what is the time taken originally, right? So here speed equals distance by time. So speed in the original situation here, let's assume the distance is given, which is 360, right? So we know this distance is 360 kilometers. So we can say if original speed was x is equal to 360 divided by the time taken initially, we don't know what that is. So let's say it was time was t. So from here we can say t is equal to 360 divided by x, right? This is the time taken originally or initially. And now in the second scenario, if the speed is more, right? So let's understand this conceptually. If you are going faster, will you take more time or you will take less time? Obviously, you will take less time because you are going faster. So you are going to cover the same distance much quicker. So in the second scenario, our speed is x plus 5 and we are covering the same distance, which is 360. And this time, let's say our time is t2 because these two are not same. I should have probably written t1 here. So now the time taken is t2, which is 360 divided by x plus 5. Now what is given is that now t2 is smaller, right? So what is given is now the t2 minus, actually I should say t1. T1 is bigger number. So t1 minus t2 is given as 48 minutes. Again, initially it would have taken more time. So t1 will be greater than t2 because in the second scenario we are going faster, so we will cover the same distances in less amount of time. So t1 minus t2 is 48. Now one quick observation, the distance is given in kilometer, the speed is given in kilometer per hour. So we want to convert this minutes into hour to be consistent. Or this will be, we can divide both sides by 12. 12 4s are 48 and 12 5s are 60. So we know this is T1, we know this is T2, and we have a relationship between T1 and T2. So let's put all of this together. So what we'll get is, we will have, let's do it over here, 360 by x minus 360 by x plus 5. This is equal to 4 by 5. Essentially, this is what our entire question boils down to. And now we have to solve for this, and we find out x, and x will be our answer. So let's try to do it real quickly. So what we can do, let's do one more step here. So it will be 360 over here times x plus 5 minus 360 times x, entire thing divided by x times x plus 5. And here we will have 4 over 5. I think we should do one other thing. So we know that 360, we can write that as 4 times 90, right? I think we should do that because otherwise we'll be dealing with very large numbers. So, okay, let's do one thing. Let's move over here. From here, let's go on to this side. And let's this time divide both sides by 4. right? So in the numerator here we will have then 90 times x plus 5 minus 90x, entire thing divided by x squared plus 5x equal to 1 by 5, right? All right, now we will do cross multiply. So here we will get, so if we were to first open this up, we will get 90x plus 90 times 5. So let's just write right now 90 times 5, which is actually 450, minus 90x. So this entire thing times 5 is equal to x squared plus 5x. Now plus 90x minus 90x, it cancels out. So what we have here is we have x squared plus 5x minus this term when it comes on the other side. So this is basically 90 times 25. So for the time being, let's leave it like that. So 90 times 25 equals 0. So now we basically have to solve this equation to find out our value of x. So here we will try to see if we can do middle term factorization. Okay, let's give ourselves a little bit more space here. So we will need, so our equation is x squared plus 5x times 90 times 25, right? So let's go over here. So now we have x squared plus 5x. Is this minus or this is plus over here? Minus 90 times 25. All right, so minus 90 times 25 equals 0. So let's see how this will actually look like. So 90 can be written as 9 times 10 times 5 times 5 times 5, right? No, I think we got an extra 5 here. And then this should be 5. So actually this is quite straightforward. We can take these two terms together and we can take these two terms together, right? So this will be 50 and this will be 45. So we can actually split this as plus 50x minus 45x. That wasn't too bad. Times 90 times 25 equals 0. So from here we can take x common. We will get x plus 50. And from here we can take 45 common. We will have x plus 50. How? Because if we take 45 common, then 2 times 25 will be 50, equal to 0. Or our two factors are x plus 50 equals 0 times x minus 45 equal to 0. So from here, if this were equal to 0, we get x equals minus 50. And if this is equal to 0, from here we will get x equal to 45. Now, what is x? X is nothing but the original speed of the train. So can speed be negative? Speed cannot be negative, right? In other words, this is the answer. X equals 45 and the unit is kilometer per hour. So the original speed with which the train was going is equal to 45 kilometers per hour.